We're going to do evaluating and graphing polynomial functions. Your homework is that entire worksheet. I know your assignment sheet says something different, but you're going to do the entire worksheet. I'll give it to you at the end of class. It's really not all that much, okay? All right, so here's some notes, just vocabulary about polynomial functions. The big thing about what a polynomial function is that it has all whole number exponents and coefficients that are real numbers. Okay? So the degree is the highest exponent value. So if you had a set of y equals x to the fourth plus x to the fifth plus x cubed, you would say that the degree of that function is the fifth. So the degree would be to the fifth power. Okay? The leading coefficient is the coefficient in front of the highest exponent value. So, for example, if you had 4x to the third plus 2x squared plus 9x minus 10, the leading coefficient is the constant in front of the highest degree. So here the cube is the highest, so my leading coefficient would be 4, a positive 4. Okay? The constant term is just this value here. It's the one without a variable, or it has an exponent of 0, same thing. And then standard form is when you write it in descending order, just like I did here. So it goes cubed, squared, 1, 0, essentially. So this is the various standard forms for the first 4 degrees of polynomials. We have a constant that just has no variable. It's just x to the 0, really. We have linear, which has a degree of 1, so that's x1. And then we have the quadratic, which we've been looking at, with the power of 2, and the cubic 3, and quartic 4. So these are what we're going to be looking at over the next couple days. All right. So the first thing we're going to look at today is direct substitution. This is something that you've seen before and that you've been doing since probably before Algebra 1. All right, it's exactly what it sounds like. It's just taking a value for x and directly substituting it in to your function for x to solve for y. So again, like I said, we're just going to solve for f of 2. It's going to equal 4 times 2 cubed minus 3 times 2 plus 5. And then you would just solve. So you would get 4 times 8 minus 6 plus 5, 32 minus 1 equals 31 would be your final answer. So all we did there again was substitute in 2 for x. Alright, so with the same equation, we're going to solve it using what's called synthetic substitution. So this is new for you guys, but it's really not all that bad. So the first thing that you want to do is write the function in standard form. So that means you need to have a cube, a squared, something to the first power, and a constant. So we would have f of x equals 4x cubed plus 0 x squared minus 3x plus 5. If you don't write it in standard form and taking account for the squared that's not there, you're going to end up with the incorrect answer. Right? Then you want to take whatever you're plugging in, whatever you're solving for, and put it on the outside right here. So we have our 2. Once we have our 2 there, we then just want to write our coefficients. Remember, our coefficients are just the constant in front of our variables, right, in standard form right here. So we have 4, 0, negative 3, and 5. And then from here, it's simply a process that I'm going to go over with you. Okay, so with the first term, all you do is simply bring it down and write it here. Bring down the first term. And then with that term that you just brought down, you then want to multiply it by 2, by whatever number's out here, and then you just write that here. So that would be 8. So here I just did times 2. So you take the number on the bottom, multiply it by what's out front, and put it here. And then the last thing you do is just add these two numbers. So 0 plus 8 is 8. And then you're going to repeat the same process again. So 8 times 2 is 16. And then you just do negative 3 plus 16, and you get 13. And then we have one more. We have to do it one more time. We have one more value up here. So 13 times 2 is 26. Whoa. 26. So that I just did that by multiplying by my 2 from out here. And then you just add 26 plus 5, and you get 31. So we end up with the same answer as we did doing direct substitution. This is just another way of doing it that we're going to use later on, but we're learning it now because it'll be easier for you guys to learn it doing simple problems, and then you can apply it with the harder problems later on. So why don't you guys try this one? 4x to the 4th plus 2x squared, 2x cubed minus 5x squared minus 12. All right, try and set that up and solve it. So again, the first thing you want to do is write it in standard form. So here we're missing the x term, so it would be 4x to the 4th plus 2x cubed minus 5x squared plus 0x minus 12. I'm going to take whatever I'm solving for, put it right here, and then I just have 4, 2, negative 5, 0, negative 12. And again, those are just my coefficients from when I wrote it in standard form. And then once you have that, you're just going through the motions. So bring down the 4. 4 times negative 2 is negative 8. 2 plus negative 8 is negative 6. Again, negative 6 times negative 2 is 12. Negative 5 plus 12 is 7. 7 times negative 2 is negative 14. Add those up, you get negative 14. Negative 2 times negative 14 is positive 28, which is going to give you an answer of positive 16. So the next thing we're going to talk about is M behaviors. M behaviors is a pretty important concept to grasp. M behavior is exactly what it sounds like. It's what is happening at the end of the graph. And we're going to look in both directions. So what is happening to the graph, to the graph of f of x, which is going to be our y values. What is happening to our y values as x goes to infinity? Okay? Is it going up to infinity? Is it going down to negative infinity? Is it approaching a certain value like 1 or 2? And then what is happening as x goes to negative infinity? So as we go infinitely to the left, what is my graph doing? Is it going up, down, approaching a certain point? Okay? And this is how we're going to see that written. So as x goes to infinity, f of x might go to positive infinity. And as x goes to negative infinity, f of x might go to negative infinity. That's just an example of how it may be written. So, polynomial graph, first degree. So essentially what I'm looking at here is x, this is just the graph of y equals x, as x goes to infinity. So that means as I go infinitely to the right, what is my graph doing? Where are my y values going? It's going to go to infinity. And then as x approaches negative infinity, so as I go infinitely to the left, what is my graph approaching? Negative infinity. Very good. Now we're going to look at what happens when we put a negative coefficient out front. So now we've introduced this negative in front of the x. So now, as x approaches infinity, where are my y values approaching? Negative infinity. Good. And as my x values approach negative infinity, where are these y values approaching? Positive infinity. Very good. So you'll notice that when we put a negative coefficient out front, what happened to my m behaviors? They flipped. Very good. So when we put in a negative coefficient, the m behaviors flipped. What degree is this to again if we have y equals x? What degree? 1. Is 1 an odd or an even number? Odd. Okay, just keep that in mind. So 1, this was odd, and this is the values we got. All right, next we're going to look at x squared, the second degree. So here, as x goes to infinity, where are my y values going? Infinity, good. And as x goes to negative infinity, as I'm going infinitely to the left, where is my graph going? We going up or down? Up, right? To infinity. So again, we see if we put a negative coefficient out front, my m behaviors are going to flip again. So now as x goes to infinity, where are my y values going? Negative infinity. And as x goes to negative infinity, where are my y values going? Negative infinity. Good. So notice now this is a second degree 2. Is that even or odd? Okay, good. So we have even. Notice with x squared, both m behaviors, left and right, are the same. Right? They're either both positive or both negative. So let's take a look at the cubic graph. Why don't you guys try and see if you can figure this one out. So we look at this, and again, as x goes to positive infinity, where are my values going? Positive. And as I go to negative infinity, where are my y values going? Negative infinity. Whoops. Good. And then we introduce the negative coefficient, and what happens? They flip again, right? What does this look very similar to? What? What do these values look similar to? Yeah, right, the values of the first degree. So here we have 3, which is an odd number that looks identical to the first degree. So what this leads us to believe is that, okay, all odd degrees are going to have the same m behaviors, and all even degrees are going to have the same m behavior, which is absolutely correct. So we're going to look at a chart that's going to be like a little cheat sheet for you. So here we have even degree and odd degree with a positive coefficient and a negative coefficient. When I think of an even degree, if I'm having trouble remembering, I always just think of the graph of x squared, because most people know that one. So x squared, this is positive, right? As x goes to infinity, where's f of x going? Infinity. And then again, negative infinity, we're still going to infinity. Okay? When with our negative leading coefficient, the sign changes. So now we're going to negative infinity and negative infinity. The sign just changed. When I think about an odd degree polynomial, I think of the graph of y equals x. So the graph of y equals x, that's a linear function, so it's just to the first power. And again, as x goes to infinity, f of x goes to positive infinity. And as x goes to negative infinity, we go to negative infinity. And then we simply, with a negative leading coefficient, those are just gonna flip-flop. And this is true for all even degrees and all odd degrees. Alright, so the last thing we're going to look at is how to sketch these using end behavior. So here we have x cubed minus 2x squared minus 4x plus 3. What degree does that have? 3, right? So degree 3. And is my leading coefficient positive or negative? Right, it's positive. So I have an odd degree with a positive leading coefficient, so I know then that as x goes to infinity, f of x is going to go where? Looking at your chart. Right, to infinity. And as x goes to negative infinity, again, we're looking at our chart at an odd degree with a positive leading coefficient. Where is it going to go? Negative infinity, good. So if I look at a graph, I know that as I go infinitely to the right, I'm going to need to go to positive infinity. And as I go infinitely to the left, I need to go to negative infinity. I don't really know what's going on in the middle. But there is one thing you can find pretty easily, which is your y-intercept. Your y-intercept occurs when x equals what? 0, right. So if you plug in 0 for all these, what are you going to get? 3. So I know this. Okay? So that's my y-intercept. And the last thing you need to know is the number of changes in direction it's going to have. So this, you look at your at your degree. This is to the third degree, right? So to find the number of changes in direction, it's just one less than the highest degree. So 2 changes in direction. What that means is you go from going up to going down. This right here is a change in direction. Okay, so I know I need to have 2 of those. So now if I'm sketching this, I know I got to hit this point. I know I have to go up here and down there. I'm just going to, make a sketch. Something like that. And yeah, it's not going to be perfect, but that's okay. That's why it's just a sketch.